The first piece in a probabilistic model is a description of the sample space of an experiment. So we do an experiment, and by experiment we just mean that just something happens out there. And that something that happens, it could be flipping a coin, or it could be rolling a die, or it could be doing something in a card game. So we fix a particular experiment, and we come up with a list of all the possible things that may happen during this experiment. So we write down a list of all the possible outcomes. So here's a list of all the possible outcomes of the experiment. I used the word list, but if you want to be a little more formal, it's better to think of that list as a set. So we have a set. That set is our sample space, and it's a set whose elements are the possible outcomes of the experiment. So for example, if you're dealing with flipping a coin, your sample space would be heads, this is one outcome, tails is one outcome, and this set, which has two elements, is the sample space of the experiment. Okay, what do we need to think about when we're setting up this sample space? First, the list should be mutually exclusive, collectively exhaustive. What does that mean? Collectively exhaustive means that no matter what happens in the experiment, you're going to get one of the outcomes inside here. So you have not forgotten any of the possibilities of what may happen in the experiment. Mutually exclusive means that if this happens, then that cannot happen. So at the end of the experiment, you should be able to point out to me just one, exactly one of these outcomes and say, this is the outcome that happened. Okay, so these are sort of basic requirements. There's another requirement which is a little more loose. When you set up your sample space, sometimes you do have some freedom about the details of how you're going to describe it. And the question is, how much detail are you going to include? So let's take this coin flipping experiment and think of the following sample space. One possible outcome is heads. A second possible outcome is tails, and it's raining. And the third possible outcome is tails, and it's not raining. So this is another possible sample space for the experiment where I flip a coin just once. It's a legitimate one. These three possibilities are mutually exclusive and collectively exhaustive. Which one is the right sample space? Is it this one or that one? Well, if you think that my coin flipping inside this room is completely unrelated to the weather outside, then you're going to stick with this sample space. If, on the other hand, you have some superstitious beliefs that maybe rain has an effect on my coins, you might work with a sample space of this kind. So you probably wouldn't do that, but it's a legitimate option, strictly speaking. Now, this example is a little bit on the frivolous side, but the issue that comes up here is a basic one that shows up anywhere in science and engineering. Whenever you're dealing with a model or with a situation, there are zillions of details in that situation. And when you come up with a model, you choose some of those details that you keep in your model, and some that you say, well, these are irrelevant, or maybe there are small effects, I can neglect them, and you keep them outside your model. So there's definitely, when you go to the real world, there's definitely an element of art and some judgment that you need to do in order to set up an appropriate sample space.